Hi, in this video I'm going to go through the week 6 function practice questions for fall 2023. So the first question asked me to write a function that can be called without any other inputs. That means no arguments, in other words. You just say the name of the function and it does the thing it's intended to do. It's going to return one nucleotide in the form of a letter drawn at random, presumably from the list of DNA nucleotides, so A, C, T, and G. So I gave you a little bit of a scaffold. In this case, I don't want it to need any inputs, at least not right now. And so it won't have any arguments inside of here. It doesn't matter. The user isn't inputting anything to the situation. It just does an analysis. So I gave you a little bit of a scaffold. And so what I'm going to give it is the letters that it wants to draw from. By habit, I usually do it in alphabetical order. It's because some of the more popular methods like to do that. So I'm going to give it a name and then return that value, mostly just out of habit of trying to show like good best practices. It turns out that if I had just left it like that, it still would have actually been fine. It would have still worked. But I prefer this method. Too far. So I can show this now. Usage example. So if I run this, it produces a random nucleotide each time I run it. If I add stuff into here, it's just like, what are you talking about? There's no input for this. There's an unused argument. You told me 111. I don't know what to do with it. Additionally, if I assign this function to a value, I won't see its output. And so I've run this. The value's been stored, but it's kind of like this, we coined this term last class of loose data. This is loose data. It's just the function that's been run. I haven't told R what to do with that returned value, so it ends up printing it. When I assign this function, it assigns, and so it has like an output for this data to store it inside this argument, or sorry, this object. And so that's what it does. Cool. The next one was print a countdown timer in seconds. One class didn't receive this one. I added it afterwards just because it seemed like you need some more easy examples. So the question was, can you make this timer script into a function? So to do that, we can just put function around it. Let's just start off with that. We'll just highlight all of that and press tab. And there we go. We'll call the function timer. I can see how it's being used here. However, I can notice based off of my use examples of how I want to use it, it is receiving an input. So I'm going to have to put something here. Now, it turns out that if I run this, it's producing kind of a weird error. It says non-numeric argument to binary operator. And that's because min is a value. It's the min function. However, I'm trying to use it here as minutes, if you can't tell. And so I'm trying to use it as an object. Now, this is bad form. I should probably change this to like something like minutes. So that's not an object already. But I still need to have a way to change that as the user. And so that means like make it an argument. So now if I call this, 3 gets passed to minutes. That creates an object inside this internal environment, which will be minutes. It will then multiply minutes by 60 to get seconds. And then it will create a vector of that total number of seconds through 1. Then it starts looping I through each of those values, starting at the leftmost value, which is minutes times 60, and then counts down to 1, sleeping by 1 second, and then printing the new value. So if I run this, I think I actually technically get 3 minutes and 1 second. So there you go. There was 1 second. So it's not perfect. I mean, I could fix that by just subtracting 1, and that would do it. Because it sleeps and then it prints off. So then the very last value, it would print off 1 second, and then that'd be done. So again, if I really wanted to do this absolutely proper, probably would want to adjust it like that. That said, in terms of usage, I use this to show you guys when it's time to move on to the next question. So in terms of a use case example, I don't really care that much. So there you go. Let me just stop that. So just pressing the stop button, or I could click down here and then press escape. Okay. If I really wanted to test that out, I could be like 0.1, 6, 5, 4, 3, 2, 1, and then it ends. That's because I haven't rerun the function. Now running that one more time. 5, 4, 3, 2, 1, 1 second of break, and then 0, and it's done. There you go. This next one wants you to convert this process into a function. Okay. Here's an example. If I run it like this, I should just be able to draw 1 in 4 nucleotides. So that's easy enough to start off with. So we're going to make a function called random nucle, or R nucleotide. Hush, puppy. Sorry. It's going to do something like what we've seen already, where it produces a object from presumably a very similar script to this. So let's just copy this to start off with, and then we'll build from that. All right. However, I want to be able to accommodate multiple loci. Okay, so apparently I named it this. So that would be the number of draws. It turns out that there is an argument you have to activate, which is replace equals true, so that way you're not using up the nucleotides. And then I also want to be able to change the things that it is drawing from. So I've clearly named it nuke vector in my examples. So if I make nuke vector a argument, we're pretty close to this. So far, if I run this one, that's currently working so far. So I drew 4 times by passing it the value 4. I then, changed the values it was selecting from. Finally, I output this. However, there was one more thing I requested. That's that I wanted it to have default values so that I could just run it by itself and it would work. So in that case, I need to provide it default values. This is how we provide default values. We put them in the original function, and this just makes that the default value. It can be overwritten. C, G. I'm sorry, my pup is freaking out. And now we can just go through and test each of these. Okay, that's working as I expected. This one, that's working as expected. This one, working as expected. And then this one, working quite well. So I just made a very large number of selections of this kind of Punnett square looking cross. So then I called table on this output. Here, I'll just show you what that output looked like. It's a whole lot of these values, so 1 million of those values. And then I called table, which you can already kind of see the pattern just within table, but just to switch those to a proportion, I then divided by the total number. So the number divided by the sum. And so I get their proportion. There we go. Next up, com nucle based on the template. Write a function that creates diploid genotypes from input. A1 is a character vector of arbitrary length of nucleotides. A2, a character vector of length that is equal to A1. delimiter, a length 1 character vector that defaults to /, and let's at least start there. Okay, so we're going to call it comnucal. It is a function, easy enough. It's got a1, a2, and delim. The only one that has a default character will be delim. And a1 and a2 need to be the same length, but it can be anything I want, so they don't have default values. Okay, the output is a character vector the same length as a1, a alphabetical diploid genotype using / as the delimiter. So I could show a very simple version that doesn't alphabetize. So not alphabetized. Wow. Not alphabetical. Let's just go with that because, wow, that was so bad, Nolan. So I could just do A1, delim, A2. And that by itself would be pretty close to right. However, that step of needing to make it alphabetical makes this much harder. Additionally, I have some requirements, but I think the next one is where I wanted you to sit there and mess around with like warnings and stuff like that. Cool. And then I also suggest instead of sticking delim in like this, you use paste O with collapse like that. Now the problem with this is that this will actually stick all of the values together, which is not what I want. I want them to be stuck one at a time. In case if A1 is longer than length 1, I need them to be stuck together like this one to this one, and then this one to this one. That's going to be easiest to do with a loop. So I provided a scaffold for this loop. So if I just come down here, I manipulate this. This won't currently work. There's a couple of issues. Let's go through it step by step. First of all, this loop is going to make I in what should go here? Well, 1 through the length of A1 would mean that I becomes each value in 1 through the length, and so that allows us to loop over the positions. So that's a very common technique. That's exactly what I want. So, cool. We can test this out by just starting with the first value. So I should be 1. So I'm just testing that out. So I just deleted it afterwards, so it's not sticking in there. That means that A1 and A2, so we need some test data to play with. So let's just kind of copy this, run that to create A1 and A2. All right, so now we have some dummy variables. Let's see if they work. Here's A1, here's A2, C and A, putting them into one object, then sorting them, and finally collapsing them together with a delimiter. Hey, we haven't run the delimiter object yet, so let's just create that. There we go. So just for the record, I forgot to mention this. As the reason I could just go into here is because when you write the function, it ends up creating these objects, either based upon the user's input as the highest priority, or if the user doesn't specify them, the default value if they exist. And so, like, as I was testing this, I had to go through and make sure I was kind of adding these in as they would have occurred inside the function. So finally, it's going to place this current genotype into the ith value of an object that doesn't yet exist. And let me just expand this pane over here so that you can see that it doesn't quite exist yet. So that means that's something that we would need to create. So I could either add this to the loop, or I could just come down here and I can see that I give an example of instantiating, so creating this object so that we could refer to it later by just creating it A1 and then doing this like handy trick of just extracting all the values and replacing them with missing data. And what's nice is that that actually saves any names that would have been on A1 and places them as names in vec out. So it's just a very handy kind of strategy for creating objects. Okay, so at this point, I should be able to just run through here because I can check to see, does that one work? Cool. The next value would be I equals 2, so I've just typed this down at the bottom. And I can test this out one more time. Yep, so it's gone to the second value, which is TC, which I can see is right. This one's also going to have worked. That's now TG, so it's going to stick it together. And if I just run the whole loop, I can see that, hey, that worked. And then it's returning vector out. So that is all the steps that I requested. Let's just add a few comment characters. So return the output value. Loop over A1 and extract each position and combine with corresponding position in A2. Cool. Let's test that out. So I've created this. It's currently running. However, I don't want to get confused because there's a bunch of objects out in my environment that also exist inside of here. That can be challenging to work with because even if there's a step that causes an error, it could still be pulling the value from my global environment from the outside. So like, let's say I had messed this up. Well, since vec out exists out here, if this doesn't produce a fatal error, I might still be modifying this old version of vec out, and that's going to cause some really weird issues. And that's just because when functions can't find an object, they start looking in the previous environment. Okay, so now I've cleared my environment. I've only run this function. I'm ready to start testing it. And it looks like it's working. Looks great. There you go. Looks like I did everything there. Cool. Looks good. All right. Next up, I say, I don't know what that was. I just pressed the word G. So the next one is manage like the inputs and outputs. This is not really function writing at this point. This is going to be more of like logical writing. Since that's the case, I think I'm just going to scroll down to my example code because I don't really want to spend a whole lot of time focused on not function writing in this video. So if I go down to my answer key, that was manage the input data. So there were several different things. I've copied them into headers for each section. So I'll just kind of talk through what each one is. So the first one I said was make A1 and A2 character types. So it's just checking, are they character types? Is dot blank is a common name for various object types. So there's an is dot array, is dot atomic, which just means is it like a kind of a simple vector type. Is dot call, I don't know what that is. I don't know, a call mode. I'd have to go look that one up. That's fun. Is it a character? That one's the one we're using. Is it complex? That's like irrational non-real numbers actually. Is it a data frame? Is it double? So that's the double precision vector, numeric type in other words, and so forth. So lots of different is dots. Very common. I then test both at the same time. I join them together with ampersand. And then I test is it, well, not both of those. So there's a lot of ways to have written that logic. I just find this one to be fairly understandable. So here is me testing the thing I want. And then I'm saying, well, is it not this? Because if it's not this, then you have to stop. I want that to stop if that's true. But it shouldn't be. They should be characters. The length can't be less than 1. So I've just tested is the length less than 1? And if it is, then hey, don't stop. It needs to be greater than 0. So I could have said equals 0. I just didn't. I don't know why. This next one says they have to be the same length. So I'm just testing, are they different lengths? And if not, produce an error. Is the delimiter length 1? If not, produce an error. This pattern continues. It's not terribly difficult. Inchar is probably the most complicated one because This could be an arbitrary length. Yes, I could have left out this all, but that would then only work if A1 and A2 were length 1. By using all, which just says are all the values true, it ends up not coercing, it just ends up analyzing it and producing a single logical value, which will control whether or not this message gets produced. That's it. So I didn't make any other changes. So the next one says, add a function intended to be used inside of com nucal. It is intended to be added after sorting the alleles. It should replace NA with in repeated, blank times the number of characters in the current allele. If both characters are missing, it should stop and produce an error. Now that's a bit tricky, but here's what's going on. It's sometimes you just don't observe a locus for various reasons. Maybe it's because there's like an actual deletion of that locus. For me, since I used to do this restriction site associated digestion, where I would digest the whole genome and then sequence on either side of it. Well, what if there's a mutation in the restriction enzyme site? Well, if that's the case, then I get no information on either side because it didn't cut there, and so I don't get sequence near that location. So for that genotype, all the information is just missing, or possibly I just have half as much information in case the other side did not have that error, or not error, that SNP. So anyways, it's a fairly common need, and so a way to represent that is with ins, just missing information in sequencing data is often just represented by the character N because it could be like a single nucleotide. Okay, so I'd say to make the symbol for this function, nucal make N. The input will be a character vector that may or may not have missing values, and the output is a character vector with missing values replaced and no other changes. And so I say use ncar to count the number of repeated characters, rep to repeat the letter in, and then pasto used to simplify the repeated ins into a single string. So here's an example. If I say that this particular, that this vector, so missing and ATG, so this would be A1 and A2, given that, it should produce in because this is 3 letters long. If they are both missing, it should produce an error. Okay, so let's see what I did. So I've given it a single input which is geno vector, so this would be the equivalent of saying C A1 A2 inside of that previous function. I say, are they all missing? So I test if they're missing, and then I call all. If they are, then I print off a message. I print their values, and I say all the values are missing, see printed values. If not, then I calculate the maximum number of characters. Save that as an object that will just only occur inside of the function. I then take those values and repeat. This is where I said to use the repeat function in that many times. And then finally use paste O to collapse those. So if I give this a dummy value, so this previous one should have been 3. We could even actually let's just do that. If I go back to that one that had an interesting result, so GenoVec. Oh my gosh, I'm all capitals. GenoVec. I can test this out. So, are these missing? True and false. All? No. One of them's false. So that one won't print off. That's good. Next one. What's the number of characters in each? Well, it's missing and 3. And so I call max, but you'll see I have to add na.rm because, well, there's a missing value in 1. I save that output to an object, maxlen. Next up, I'm going to repeat in 3 times based upon that number that's there. So in. Saving that. Then finally, I'm extracting the missing value and replacing it with the missing genotype. And then returning that. So there you go. There's your nuchal make-in with the explanation. And so in terms of where I would place this within the function, that step is a little bit complicated. But essentially, I made a toggle argument that would allow me to turn this behavior on and off. Did I actually say to do that? I got it a little bit complicated. But that's what I did, is this was just toggling on and off this behavior of whether or not it should occur. Yeah. So toggle make in is going to work if the this little toggle has been activated. This is a very common strategy that I take, where I just add a logical argument to a function in order to turn a behavior on or off. Just like, I don't know, remove na.rm is a logical vector that turns off or on a behavior. So if this is turned on, then each time it calls sorted alleles, it runs through that logic, and it outputs the vector if needed. If it's not, then it just skips that step. And so you'll see I actually overwrite sorted alleles, so that way it can be optionally skipped if needed. Cool. And that's the idea. So hopefully that helped. If not, maybe now that you watch this, go try that on your own with some of this background knowledge. It really is a skill that you develop over time. You're really starting to dip into some of the art and just really the computer science of things. And just for the record, like I said, this is really the most advanced kind of stuff that this class gets to in terms of programming. This is a skill that takes some time to develop. So embrace this the rest of the class, like start working on functions and trying to kind of write little small functions so that you're writing kind of prettier code that's more flexible. And if you do that, then you'll get good enough and you can take some more advanced coursework and really start to use this skill. I mean, that's basically how I got started in all of this. So good luck and thank you.